Hi, today we're going to take a look at solving three-variable, three-equation systems of linear equations. As a prerequisite to what we're doing, you need to make sure that you can solve the two-variable, two-equation systems of linear equations using the elimination method. If you're not familiar with that, please go back and make sure you got that down first. Some guideline steps to help you solve these. Remember, the goal is to eliminate a variable so that we create a two-variable, two-equation system of linear equations. So the idea is to reduce it down to something that you're familiar with. In doing so, we're going to pick a variable to eliminate when we add two of the equations together, which is similar to what you've done in the past. You'll start by picking two equations. You'll eliminate the variable that you want. Then the goal is you're going to pick a different pair of equations and eliminate that same variable. After that, we're going to take the results we got, which should have only two variables. Hopefully not more than that. And when we've done it twice, we'll have a two-variable, two-equation system, which is what you've normally done. So we'll use that to eliminate, using elimination to solve for all the remaining variables. And then basically we're going to back substitute to find the other answers. And of course, you always want to check your answers. Let's start with the first example. In this case, you're going to want to eliminate either the x's or the z's. They should work fairly easily. Now, while I'm thinking about it, you may want to pause the video on occasion as I work through this, as I prep some of this ahead of time to make sure the video stays fairly short. Alright, I've decided I'm going to eliminate the x's. So I've numbered the equations so you can understand which ones I'm going to be working with. My first step is I'm going to work with equations 2 and 3 to eliminate the x's. Now if you remember the elimination method, the goal is to add the equations together to get something to cancel out. In this case, we don't need to do anything special. We have the negative x and the positive x, which when we add them together will cancel out right away. So when we add the two equations together, those are going to cancel out. We get the minus 2y, the minus z, and a positive 1. Alright, now we need to pick a different pair of equations. Since we use 2 and 3 here, 1 has to get used next time. In this case, I've decided I want to use equations 1 and 3 from the beginning. Now, if we look at them right now, the negative 4x and the positive x do not cancel out if I just add them right away. So if you remember from the elimination method, you can multiply one of the equations by something to make that happen. In this case, we're going to want to multiply the bottom equation by 4. So I'm going to take a second and rewrite out the first equation, and now I'm going to distribute the 4 through the second equation. Please remember you have to distribute the 4 to all of the terms in the equation. Let's take a look at that. Now when we add the equations together, the negative 4x and the 4x will cancel. We'll get the 13y minus 7z equals negative 20. If you look at what we've done, in both cases we've eliminated the x, which has now left us two different equations that have y and z in them. So if we put those together, we have a two-variable, two-equation system of linear equations. We're going to go through the same steps that you normally do to solve this using the elimination method. In this case, I've decided I'm going to solve by eliminating the z. To do that, I'm going to multiply the top equation by negative 7. That is 14y plus 7z and a negative 7. Rewriting the bottom equation. Should be there. Now when we add, we're going to get 27y. Positive 7z, negative 7z cancel, and we should get a negative 27. At this point, divide by the 27, and we're going to get y equals negative 1. At this point, we're going to back substitute. In this case, I'm going to back substitute into that blue equation. So we have the -1 for the y to put in there. So if we do the math, we got +2 minus z equals 1. Subtract 2. -z equals -1. Once we divide to get rid of that negative sign, we see that z is going to be a positive 1. And finally, at this point, we're going to back substitute all the way back into one of the first equations. So we're still putting that -1 in for the y. We're going to put the 1 in for the z. And we're going to solve. At this point, we'll add the like terms. Let's try that again. -3 minus 2 should be a -5. Hope you were paying attention. Alright. Add 5 to both sides. And we should get x equals -2. So overall, our answer, if we listed it as a point, three-dimensional point that, we got -2 for the x, -1 for the y, 1 for the z. You get a second, plug that into either of the other two equations. Actually, probably be good to plug it into both. Double check to make sure your numbers work out fine. All right, let's try a second example. In this example, well, it looks fairly easy to cancel out the x's in the first two equations. Thinking in terms of the fact that we got to do this twice, I'm going to pick the z's to work with because all of the z coefficients are even. So if I look at the first and second equations, right now we're pretty close to getting them to cancel out, except both of them are a -z. So I'm going to want to multiply one of the equations through by a -1 to make sure it works out. So if we do that, we're going to get +3x minus 5y, +2z, and a -9. I'm going to keep the bottom equation the same. Now, when we add these together this time, change out the 3x minus 3x cancel out. -5x plus 6y will leave us a y. Z's also cancel out. So in this case, we end up with y equals 2. Hey, that's a bonus when you get two variables to cancel out once. It works nice. Now, since I've decided I'm eliminating the z's, still do that again. This time we have to use equation 3 in addition to one of the other ones. So I've decided to use equations 1 and 3. Now, to make these cancel out, I'm going to multiply the top equation by a 2. We should have -6x plus 10y minus 4z equals the 18. We got -5x plus 4y plus 4z equals -1. Just rewriting the second equation down. If we do the math now, when we add the equations together, we should get -11x. We should get plus 14y. The z's cancel out like we wished. And that equals the 17. So now we take the results from those two sets, put them together. And actually, we're in good shape because now we can just back substitute straight in. We got -11x. We already know the y equals 2. So if we do our multiplication, we're going to get 28 there. Do our normal solving by subtracting the 28. Divide by -11. So it looks like x is going to equal 1. And then we got to go back to one of those first equations so we can figure out z. So here, we know that the x is 1. We had 2 for y right away, and we're trying to solve for z. So we do our math, we got the -3, the +10, and the -2z equaling 9. add our like terms. Subtract. And then finally divide by the -2. In this case, z should be -1. So the three-dimensional coordinates we should have for this should turn out to be 1, 2, and -1. Once again, if you get a second, please go back and double check this in your other two equations. I know this was fairly quick, but I was trying to get through 2 examples in a fairly short time. If you have any questions, please see your math teacher or email somebody for help. Thank you.